Now, that sound means it's time to take the double derivative. Kids at home, follow along. All right, take the 2, break it down. I guess I'll do 2 times 27. No, always look for the cross cancel, right? So wouldn't it be 27 halves? X plus 2, x minus 1 to the -2. And the chain rule of the original base is actually 1, but think it though, think it. Because as soon as that's a 3x minus 1, up, think 3. Now, double derivative would be something 27 halves, 27 halves, minus 4, x minus 1 to the 3. Again, the chain rule is 1. Okay. So your official double derivative is this right here. Okay. All right. Now we're looking for inflection points. Okay. So we need a number line, but first we need to figure out what to put on the number. Okay. Let's start with case 1. Find the neutrals, because the neutrals are possibly inflection points. Okay, so let's set that equal to 0. And let's see, what should we move?
27.
You could, or
Keep it positive.
if you want to keep it positive, you move that one. It's just the same answer either way, right? I like to keep my 4 over x minus 1 cubed as a positive, since I encounter them all the time. And so we'll move that over. And now with a little bit of, it's kind of cross multiplication. It's basically rearranging things. I don't like the x in the bottom here, okay? I'm very confused, all right? I'm on a pool float for 3 days. Remember that old classic, right? Okay, but it's gone now. Okay, a void just flew out of me.
Did you see the new Mayhem commercials?
I'm not yet.
Yes.
I'm still sad about you.
The dog collar one?
Oh, I haven't seen that one yet. I gotta check that out. Okay, so why don't we, I don't like the x in the bottom. Why don't we get the x in the top by multiplying? Any idea what to do with 27 over 2? You know what? Not yet. I just moved this up here. I need to get that over there. I could reciprocate it and go like that. If you reciprocate it, won't that make 2 over 27? And what is 2 times 4?
8.
8 over what?
OMG.
Oh, look at this. You're welcome.
Breakthrough.
Hey, breakthrough. All right. A nice handcrafted problem from me to you. All right. Enjoy it. It just so happens that the cube root of 8 over 27 is very nicely 2/3. All right. And if you don't appreciate that, I'll just give you 17 over 59 next time. Okay. No, what's you deal with that one?
I like it.
Okay, but okay, yes, it's very nice, isn't it? Right? Take the time to work all these backwards for you. Okay, add 1 to the other side, and 2/3 plus 1 is 5/3. All right. Take it, put it on a number line. But wait, there's more. If you act now. Today's theme is to look for the D&E's, right? Because D&E could separate the worlds of plus or minus. So I need another bit of camera pointing out here so you can see what I'm seeing. All right. Now, let's go back here. Is there a place where this function is non-existent?
At 0.
At
1.
At D&E and x equals 1.
How have we done that?
Okay, we got a roach in the biscuits. Okay, roach in the biscuit though. Oh, Mr. Wade, you just got a 0 right here. 4 over 0 is D&E. What about the 27 over 2? It's out. Throw it out. Okay, it's gone. Okay, well, you get a little roach in one. You don't just cut it out. You throw away the whole thing. Well, I would cut it out. Personally, being German or being careful, cautious. Okay, so anyway, 27 over 2. This is germaphobe, but I'm not. Okay, 27 over 2 minus D&E makes the whole thing D&E, so that is a very important place right there that you have to mark. Because if you don't mark it, you might pick 1 as a sample point and go, what happens? Okay, 1, 5/3. Okay, you have to lay out all the things that are not negative and not positive, so that when you plug in sample points, you only get positive.
What's going on?
So, 1, 5, oh, wait a minute, we learned something today. Mark it.
Yes.
The 1 is the D and E case, and this was the neutral case, or you could say F double prime goes 0. Okay? Difference, there's a difference. Okay, let's plug in 0.
Negative Google.
Okay, or negative Google. We'll just type squeeze here.
1/2.
4/3 would be good. 3/3, 5/3. 100. Okay. All right, let's take it, plug it in to this. Okay, 0 minus 1 is negative 1. Negative 1 cubed is negative 1. Negative 4 over negative 1 is
Positive 4.
positive 4. And 27 over 2 plus 4 is positive. Notice I cannot today play the plus times a minus as a minus game, and the minus times a minus as a plus game. You know why?
Derivative.
You don't have multiplication, we've got subtraction, so you have to kind of work it out in your head, right? Okay. All right, 4/3 minus 1 is 1/3. 1/3 cubed is
1/9.
1/27.
27.
Flip it over though, and it becomes 27. If I had half a 27, take away 4 27s, I'd be in negative territory. If I had half a dog and I took away four dogs, dogs are 27s, I have negative dogs now. I have 3.5 dogs. Kind of gruesome. All right, anyways, the point is, you get negative. All right, 100 minus 1 is 99. 99 cubed is
Big number.
gigantic. But 4 over gigantic is practically nothing. And 27 over 2 minus insignificant is positive because you're not taking away anything. Okay, and there you go. All right, question. How many inflection points do we have? Was the question. Well, we got 2 sign changers.
One's a D and E.
Oh, this is leading to the moral story. Now, let me tell you this. You can have a D and E case actually produce an inflection point. We'll have one soon, believe it or not. But here's the true test. Here's the moral. If you're going to write this as an inflection point, don't you have to plug it back into the
Original equation.
original equation to get the what?
Y coordinate.
The y coordinate. If you plug 5/3 back into the original equation, would that be any problem at all? Okay, it'd be kind of a pain to do, but it works.
What would it be?
But, well, a big mess, okay? But if you plug 1 back in, see this right here,
0.
okay? Roach in the biscuit dough, the whole thing does not exist, okay? You can't have the point 1 comma D and E, that's not a point. So you can test it to make sure, and you will see that you only have 1 inflection point here. So the answer is just 1, okay? So this is kind of the third moral. I didn't write moral of the story, but here's the third moral of the story. Write this down somewhere. To truly have an inflection point, you must have 2 things. F double prime must experience a sign change, but one more thing. The original function has to exist there. Right? And there are some weird cases we'll do in this chapter where it's D and E, but you can plug it back into the beginning. I'll show you why that happens. Okay? So you can have an inflection point in a D and E, but not if the original function is D and E. That's where you have to check it right there. Okay? So those 2 things. If you pass those 2 things right there, you're good. If you know the 3 morals, that's all I want you to know about the second derivative test. Even all the way through calculus, that's it. Okay? It's all out. All right? We got your 1225. Piece of cake, we got this.
Wait, what is that?
Okay? That up there? Okay, so an inflection point, that's just abbreviation. So to get an inflection point, the double derivative has to have a sign
You
change.
did 2 B's.
Plus, the original function has to exist. That's not fexes.
There's 2 B's.
Huh?
You did 2 B's.
Two B's. Oh, no, that's going to be on the front page. That was supposed to be unlabeled on the front page. Self, fix that for next year. Okay, Now.
Plus 10. You did
all right? So that's supposed to label one on the front page. All right. So, you kids, all right, C, for what values of x is this graph concave down? Where should we look for concave down? Downward concavity.
Negative.
That would be where it is negative on the double derivative test, right?
1 to 5/3.
But it says for what values of x, not for what interval. So it's a slight difference, right?
X.
Use the, no, not those.
The greater than and less than.
Yeah,
sign.
which are also known as
Inequality.
inequalities, yes, very good. Use the inequalities. You said it? Yes, very good. I thought somebody said so. Okay. Use the inequalities, not the interval. You'll only get a -1 if you don't. It's not a big deal, but try to follow directions. For what values of x? Okay. On your paper, start listing every number in the world between 1 and 5/3. Okay. If we had a Googleplex number of years, you still couldn't list every number between 1 and 5/3, could you? They're infinite. No. It's infinite numbers. You can't do it.
Watch.
Okay, oh, you try. Start now. Okay, call me when you're 70. All right. Now, values of x. Here's a way to describe every number between 1 and 5/3. 1 is less than x, which is in turn less than 5/3. So it kind of looks like an interval, but it's with inequality, right? Okay. That's it. If I said concave up, then you would give these two answers, and you'd have to use the word or. Good, remember, very good. So basically, if you have two plus signs, you use two expressions. If you have one negative sign, you use one expression. Okay? And there you go. That's it. Okay. All right. Last one's easy. It's a new trick. It's a new trick, but it's easy. Normal line. What in the world is a normal line? All right. Here's an example. Remember in geometry, everybody's favorite class?
Tangent line.
Yep, tangent line.
That's good. I like that class.
And if it's tangent to a circle, it must be so balanced that it intersects the radius at a right angle. Okay? Perfectly balanced. If that angle is not 90 degrees, it's not perfectly balanced. And that's pretty much the same with all these curves we've been doing too. It has to be balanced, right? The normal, the normal line is the one that goes straight through that point that is perpendicular to the tangent. It pierces right through the center of the shape. Or like in a parabola, it'll try to go right through the middle through the vertex of the focus there. So it's headed right to the middle. Okay? So that's what a normal. There are a lot of real life applications of normal lines we'll use later on. Okay? So normal line. How do you pierce right to the middle? Okay? So here's what we do on this one. A normal line. Isn't a normal line still a line? So that means we still need the same ingredients as we do for a tangent. X, Y, and anytime you see the word line in math, get X, Y, and tangent, normal, just a line segment, they're all the same.
What's the original equation?
Well, the original equation, we're going to use the same equation we had over here. Okay, for this formula. All right. Now let's see. If you take 0 and you plug it in there, can we get a y coordinate?
No.
Sure you can. That's 0.
That's negative, that's 2.
So it's going to be positive 2, isn't it? Right? Okay, positive 2 is your y coordinate. That's your point of tangent. Okay, or normalcy in this case. All right. Now, how do we get the slope?
Plug it into the first derivative.
Plug it into the first derivative right there. Okay, 0 wipes that out, and you would get 2 over 0 minus 1 squared.
So
When it actually squares a negative 1, it makes it positive. So you actually get 2 as well. Now be careful, because you know what the derivative gives you? The derivative gives you the slope of the tangent line. So how do we convert it from tangent to normal? Do you remember the symbol for perpendicular from geometry? The perpendicular slope means to reciprocate and
negative.
make it the opposite side.
So negative 1.
-1/2. Yep. In this drawing, the tangent was negative, but the normal was positive. Okay? And then just take that and plug it into y, so it's supposed to be. And I'll go ahead and cut to the chase with it. It's negative 1/2 x plus 2. Oh, I'm so surprised. Okay. And there's your answer. So normal lines are a lot like tangent lines. Just flip it over. All right, how's that? Make sense? Catchphrase.
So keep it off. Here's the red button for you.